All right, we're going to play a little game. We're going to start with the numbers from 1 to 10,000. Yeah, I know I've just got 1 to 10 here, but you're going to write 1 to 10,000 at home, all right? And you're going to put up arrows next to one up arrow next to each number, all the way 1 to 10,000. All right, I'll give you a few seconds there to write it down. All right, you got it? Good. All right, so we're going to start with up arrows next to each of our numbers from 1 all the way to 10,000, all right? And here we're going. We're going to do on our first step, we're going to go through every single number. We're going to flip the direction of that arrow. All right, so here we go. Here's my first step. And you can keep going. I'll let you finish all the way up to 10,000, okay? All the arrows from 1 all the way up to 10,000, you have them pointing down, right? You got that? Great. All right, now, I kind of cheated there. All right, I'll go ahead and draw the arrows for the rest of the steps. So, but you have to draw them too, all right? Great. All right, so next step. We're going to go through and we're going to flip arrows again, but this time, instead of flipping every single arrow, we're going to go by twos. We're going to flip 2, we're going to flip 4, we're going to flip 6. So let's see, 2, it's pointing down now. We're going to flip that over. 4, we're going to flip that one over. We'll flip 6 over, flip 8 over, and we'll flip 10 over. And you keep on going through all 10,000. You'll do 12, 14. Okay, I'll give you a second. Great, you're done. All right, good. So now we're going to go on to next step. We're going to do 3s. 3, 6, 9. And on each number, we're going to flip the arrow over again. So 3, that one's pointing down. We'll flip that one up. 6 is already pointing up, so I have to flip that over. Point that one down. And see, 9 is pointing down, so we'll flip that over and point up. And you can keep going. 12, 15. You're done? Good. All right. Next step, of course, we did 1, we did 2, we did 3. Now we're going to do 4s. So 4, that one is pointing up. We'll flip that one to point down. 8 is pointing up as well. We're going to flip that one to point down. And you just keep on going. 12, 16. Meanwhile, I'm going to go into the 5s, all right? We'll do the 5s. That one's pointing down. We'll flip that over to up. And then 10, that's pointing up, so I'm going to flip that one over to down. And then you keep going. Good, you're done. 6, we'll go to 6s. Let's see, that one's pointing down. We'll flip that one over to up. And I don't have any more numbers in my list for the 6s, because that's going to go on 12 and 18, and that's the rest of your list. All right, on to number 7. We're going to do the 7s. That's pointing down. I'll flip that one to up. And then onto your list, 14, 21, and so on. And then, well, we'll do 8s after the 7s. So 7, that one's pointing down. We're going to flip that one to up. And then onto your list, 16, 24, all the way through all 10,000. Then we go on to the 9s. Every 9th, we're going to flip the arrow. That one's pointing up, so we'll point that one down. And then you're 18, 27, 36, and so on. You flip all those arrows. And then finally, I'm going to go into the 10s here. 10s, I'm going to have to flip this down arrow to an up arrow, and then you're 20, 30, 40. Now, all the rest of the steps, you have to keep going. Do 11s next, then 12s, then 13s, then 14s, all the way up to 10,000. But see, I don't have to do anything else because none of those are going to affect my 10 numbers here. All right, so I'm going to give you a couple seconds to finish. Do all the way up to the 10,000s. All right, great. So you got your whole list there. All the 10,000, some of the arrows at the end are pointing up, some of them are pointing down. Now here's my question. How many of the arrows at the end next to the numbers are pointing down? The final arrow, that's the only one we care about, is the arrows at the ends. So here, 1 is pointing down, 4 is pointing down, 5's up, 6 is up, 7's up, 8's up, oh, 9 is down. All I care about is which direction the arrow is pointing at the end. 1, 4, and 9 are all pointing down. All the rest are pointing up. Hey, those are perfect squares. Take a look at your list, too, and look at the rest. See if it's just the perfect squares that are pointing down. It is? Oh, man. So it must just be the perfect squares from 1 to 10,000. Why does that happen? Why are all the squares pointing down and the rest of the numbers pointing up? Oh, what's going on here? Well, let's think about when the arrows switch. All right, so we got these are all down. That means they switched an odd number of times. This just switched once. 4 switched 3 times. It went down, then up, then down. And then 9, that switched 3 times as well. Went down, up, down. Now take a look at your 16. All right, see that? I'll bet that one goes down, then up, then up, then down. That one switches 5 times. So they switch an odd number of times, that makes them go down. If you switch an even number of times, look at 6. Down, up, it ends up. So it looks like that the squares will switch an odd number of times, and all the rest of the numbers will switch an even number of times. Now what's going on when they're switching? Well, let's take a look at 4. 4, it switched when we did the 1s. When we did every single one. Then it switched when we did the 2s. And it switched when we did the steps, the 4s, 4 and 8 and so on. So it switched on 1, it switched on 2, it switched on 4. Those are the divisors of 4. Let's look at 6. That one also switched on the 1s, it switched on the 2s, it switched on the 3s, and it switched on the 6s. It switched at 1, 2, 3, and 6. Those are the divisors of 6. That makes sense. When we're going through and counting by 3s, we're just going to hit the multiples of 3. And that's when we're going to switch. We're going to switch arrows, and we're going through by 3s on any multiple of 3. So if a number has 3 as its divisor, its arrow is going to get switched when we go through by 3s. And when we go through by, so when we go through by 4s, we're not going to hit 9, because 9 isn't a multiple of 4. So 9 won't get its arrow switched when we're going through by 4s, 4, 8, and 4 is not a divisor of 9. So this tells us when the arrows switch. An arrow will switch when we go through by a divisor of that number. Whenever we go through by 1, 3, or 9, we'll end up switching 9, because those are the divisors of 9, and we'll hit 9 when we're going through. So now our question is, why do the squares have an odd number of divisors, and the non-squares have an even number of divisors? How do we count up the divisors or tell if there's an odd or even number of divisors of a number? Well, let's take a look. We'll take a look here. How do we find divisors of 6? We'll start with 6. Well, of course, that's just, there's 1 times 6 is 6, and 2 times 3 is 6. Divisors come in pairs. They pair up. 1 and 6 go together and make 6. 2 and 3 go together and make 6. So it looks like divisors, there's always going to be an even number of divisors, because they can always pair them up. You have one divisor, you're going to get another one, because it's a divisor. That means you can multiply it by something, some other integer, to get 6. So I start with 2. It's going to be, I can multiply it by 3. I get 6. So 2 is a divisor of 6, but then 3 is as well. So it looks like the divisors always come in pairs. So we should always have an even number of divisors. But what was up with the squares? It looks like they have an odd number of divisors. All their arrows are pointing down. Let's take a look at 4. Well, 4, of course, we have 1 times 4 is 4, and then 2 times. Aha! When you have a perfect square in one of these pairs of divisors, both of the divisors are the same. It's the number that you square to get 4. So I'm going to have 2 and 2, they're both divisors, but we only count them once when we count our divisors. And this will happen with any perfect square. Let's take a look at, you got 16, right? 16 on your list, that's pointing down. Let's take a look at that. For 16, we have 1 times 16, you have 2 times 8, and you have 4 times 4. And right there, that's why we have an odd number of divisors. They come in pairs until you get to the number whose square is 16. That one's repeated, you only count it once, and that makes an odd number of divisors for perfect squares. But this never happens for a number that's not a perfect square like 6. So those divisors always come in pairs, and you end up with an even number of divisors. So sure enough, back here, it's going to be only the perfect squares that have arrows pointing down. So now our problem is just to count the number of perfect squares from 1 all the way up to 10,000. So, you can go ahead and count them on your list, or you can realize that 10,000, that's just 100 squared. So our squares are 1 squared, 2 squared, 3 squared, 4 squared, all the way up to 100 squared. So we know that there are 100 numbers with their arrows pointing down, and we are done.